So these are the contents of this video session. Activity diagram are generally called as object orientation flowcharts. It has two major components. One is called as activities, that is actions which is performed, and next one is called as transitions. Transitions are flow between any two activities. So such activity diagram is mainly used to model the behavior, that is the working of any particular thing such as use case, classes, interfaces, components, nodes, operations, methods, etc. Activity diagram is mainly focused on communication perspective. That is, communicating one specific aspect of a system. Remember students, you cannot draw the activity diagram for your entire application. You are in need to focus on one particular specific aspect of a system, which is called a scenario. For each and every scenario, you can draw specific activity diagram. For example, if you consider ATM management system as an application, so for which there are many scenarios such as login, withdraw amount, deposit amount, etc. So each and every particular specific aspect or a set of action is called as a scenario. For each and every scenario, you are in need to focus on the activity diagram. Next, we'll get into the next concept called as action states. Activity diagram contains either action states or sub-activity states. Action states means these are the finest granularity building block of any activity diagram. So you cannot furthermore divide this particular action which is done by the specific component. But sub-activity states are a nested collection of such actions. The notation of this action states and sub-activity states are rounded rectangles. So this is a rectangle which has curved ends at both the sides. You cannot have a rectangle with perfect boundary. That is not the right notation of action states. So within such particular notation, you are in need to write the name of an action. It can be an expression or it can be a verb phrase also. Next, we'll get into what is actions in detail. Actions are nothing but a piece of work that is executed by any particular object or a class. Actions are the tasks that cannot be broken down into subtasks. Remember students, we have an activity called as login. Login may be an activity, but it cannot be an action. Why? Because there are multiple steps inside login. For example, insert ATM card, that is the first activity. Enter password is the second activity, and then followed by check the authentication, that is the third activity. So these activities can now be an actions. Why? Because this cannot be further divided into sub activities. An action can be either a pseudocode, verb, or a verb phrase. So as we have discussed in the previous line, we can write the action name as active alarm, which is a verb phrase, or it can be simply an expression like a pseudocode. Both are possible. There are three major conditions for actions. First one is that it should be atomic, meaning is that, as we have already discussed, it cannot be broken down into smaller pieces. Next one, it should be uninterruptible. So whenever an action is executing, no other actions, no other possibilities can interrupt such particular action. And third one, it should be instantaneous, meaning is that it should consume only insignificant amount of time. That is, we cannot even measure the time which is required to complete such actions. Next are the two special states which are present in an activity diagram. One is called as a start state, which is nothing but a dark curve. Other one is called as stop state. We call it as a bullseye icon. So start state is used to mention which particular activity is the starting of the activity for the complete scenario. And stop state is going to say which is an end of the activity for the complete scenario. Next target is sub-activity states. As we have already said you, sub-activity states are a collection of actions. So they are non-atomic. They can be broken down into other sub-activities and even can have multiple actions inside it. So the three conditions which are there for actions will not be there for sub-activity states. Meaning is that it can be interpreted and also it may take finite amount of time. That is, it is not instantaneous and it can be interrupted also. The notation of this is again a rounded rectangle, but within this you can see a set of activity icon which is present over here. So this is used to say display menu is not an action, but it has many other actions inside it. That is, it is a sub-activity state. This is also called as nested activity graph because it may contain action states and even a subactivity state may contain some other subactivity states inside it. This invokes the entire activity graph that is nested within it. The third component is called as transitions. So whenever any action or activity is said to be complete, immediately the next activity will be triggered. So the flow of control from one action to another action is done by something called as transition. So transition is represented by an arrow mark. This is also called as an automatic transition. Why? Because the transition will not be triggered by any specific event. As soon as one activity is completed, immediately the transition is triggered and the next activity will start to execute. This is happening automatically. This is a complete activity diagram. You can see here there is an initial start state and finally we can see a stop state. Within this we have three different actions: write letter, address letter and post letter. So in all the three states we have used verb phrase as a representation. In between the activities, we have something called as transitions, which is given by arrow mark. Remember students, here the flow of control is sequential. That is, there is no branching or looping anywhere. It starts from the first state and goes sequentially to the last state. Apart from the sequential flow, we can even have alternative flow as well. So for that we have something called as decisions. Decision specifies alternate paths based on certain Boolean guard conditions. So the notation for this is a diamond symbol. So using diamond symbol, we can specify under what condition the transition has to flow in one way and under what condition the transition has to go in some other way. The same symbol is used whenever we have a merge operation as well. That is, if there is two diversions, the diversion can meet at one point because ultimately we have one stop symbol. So such particular merging operation can also be done using the same diamond symbol. So such decision path will have one input path and multiple output paths. So each and every path we have certain guard expressions. So this is an example diagram for decisions. You can see here there is a get mail activity, after which you can see a diamond symbol. So this diamond symbol is used to denote the decision. So the diamond symbol has two branches over here. One says whether to check whether it is a junk mail. So if it is a junk mail, then the mail is saved inside bin mail or spam mail folder. Else, the opposite condition says it will be saving in normal inbox or open mail folder. And you can see there is a merge operation as well because there is one stop icon over here. So two conditions, two branches will be merging in one particular point. Such particular merge operation can be done using the same diamond symbol. So remember students, where all you have decision box, it is better to have a merging operation as well. Next is called as forks and joins. So this is used to represent concurrent flow of events. So remember students, we can go for the previous diagram. For decision parameters, we can say there are two different flows, but only one flow is executed at a time. For example, based on this condition, if the condition is true, the control goes in one flow, in one direction, else the control goes in the other direction. But there are some situations where the control goes in two directions concurrently. So that can be expressed using forks and joins. Fork is a symbol which is used to split the concurrent flow of work. It has one incoming transition. For example, from one transition, I can go for multiple outgoing transitions. So this symbol is called as fork. Other one is called as join. It is used to merge concurrent flows. So which have multiple flows in that. When all the multiple flows are completed, output one flow will be triggered. So the outgoing transition only fires, so this transition fires only when all the incoming transition get executed. If one transition does not get executed, the particular control will wait over here until all the transition gets triggered to trigger the final outgoing transition. So this is a representation of fork and join. You can see here there is a design new product activity. Once that is completed, both the activities such as market product and manufacture product will execute concurrently. Similarly, after this manufacturing product is completed and also after sell product is completed, the next activity called as deliver product will execute. So this symbol is called as join, where you have multiple incoming transitions and one outgoing transition. The next parameter is called as swim lane. Swim lane is mainly used to partition the activity diagram. So the advantage of the swim lane is that, so you can see the previous diagram, that is for fork and join. So by seeing this diagram, we cannot understand which activity is performed by which object. So for example, you can see here there are 5 activities over here. One is called as design new product, market product, manufacture product, sell product, and finally deliver product. All these activities are not certainly executed by one object at all. So multiple objects will be taking place in this particular activity diagram. So to show which action is executed by which object, we can have something called as swim lanes. So the main advantage is to divide the activities done by a particular component, that is an object or an organizational unit. So you can see this diagram. So this diagram clearly says that the activities such as design new product, market product, sell product, these 3 are executed by marketing team persons. And manufacture product is executed by manufacturing unit, and finally deliver product is executed by delivery unit. So in your lab experiment, you are in need to include swim lanes to identify, to demonstrate which actions or activities executed by the corresponding objects. So for such swim lanes, you are in need to divide your work area into various partitions, that is vertical lines. So within the vertical lines, just mention the name of an object at the top middle position. Below the space, you are in need to draw all the list of activities which is executed by that particular object. So this representation is called as swim lanes. The next concept is called as object flows. So activities which are executed may produce or it may consume certain objects for its execution. And also it can modify the state of an object. So that, as we have discussed in sequence diagram and collaboration diagram, we can demonstrate such object states in activity diagram also. So you can see in this diagram, the first activity which is done by marketing person is design the new product. So as soon as this activity is completed, you can see an object is created, which is called as product specification. Similarly, when sell product is completed, you can see the order is generated, which is said to be in paid state. Similarly, after deliver product activity is completed, you can see order has been moved to delivered state. So such particular object representation, the output objects and also the state of an object can be demonstrated using activity diagram. The last part of this video session is called as signals. Signals is a way of representing an information from one activity to another activity. So this is done asynchronously, meaning is that whenever a signal is initiated by the sender, it can be received at any time by the receiver. So you cannot say sender and receiver should be always, it should be on at the same time. And there are 2 notations. The signal sent is represented by convex pentagon and signal recipient is represented using concave pentagon. So you can see in this diagram, we have a mail order. Immediately, an order signal is created and an object called as mail order company will be created. After the object creation is over, it sends a signal which is received by means of goods delivered icon. So this is called as signal sending and signal receiving idea in activity diagram. So by this we come to this end of this video session. So here we have discussed about activity diagram and various components and notations which is present in activity diagram. So all the pictures and representations are referred from the book cited here. Thank you for your patient listening.